Hey, good morning, everybody. Welcome back from winter break, and we're going to continue with our chemistry unit. This is going to be part 2 of our chemistry unit. So today we're going to demonstrate a lot of the knowledge. We're going to kind of review what you learned on the first chemistry part 1 test, and then we're going to get into something called valence electrons and how many of them are found in each atom, and then where they're going to be found within that atom. So we're going to be able to correctly place them within the atom model. Today, your job is to take notes on the ed puzzle that you're completing right now. Attend your meeting if you're with me after you've watched this video. If you're with Mr. Oleg, it's before. He's at the beginning of the hour. And then for my class only, there's going to be an algebra review game. What you're going to need to do is take a screenshot of your score. If you have issues doing that, you can take a picture of it on your phone. If you are on a computer and you don't know how to do that, it's a quick Google search how to do that. You can also just take a picture with your cell phone. So if you got your phone, take a picture of your screen and you submit that. So that's part of your homework today too. So the algebra review. All right, so let's get started. So as a review, what do I need to know from that first test? That big picture idea is that a proton has one atomic mass unit. It's found in the nucleus, and it's a positive particle, right? It's +1. Neutrons don't have a charge, but other than that, they're just like a proton. They have an atomic mass of 1, and they're also found in the nucleus. And then electrons are different because electrons have a negative overall charge. They don't have any mass. They have 0 AMUs, and then they're found outside of the nucleus. They're going to be in what we call the electron cloud, and we're going to get a little bit more detailed with electrons here as we come forward. Other big picture stuff you need to know: atomic number is equal to the number of protons. The mass number of an atom is equal to the number of protons plus the number of neutrons. And then the charge of an atom is equal to the number of protons minus the number of electrons. If we have more electrons than we have protons, we're going to have a negative atom. If we have more protons than electrons, we're going to have a positively charged atom. And a quick review on radioactivity. Alpha decay, it occurs when 2 protons and 2 neutrons are ejected from the nucleus. It's like a helium atom with a +2 charge. It's slow moving and it doesn't cause a lot of damage. Beta is a little bit more energetic. A neutron breaks down into a proton and an electron. That electron gets shot out of the nucleus, right? And that beta particle, that electron, has a -1 charge. And then gamma decay occurs when there's a little bit extra energy inside of that atom, and to be in a more stable state, it will eject that energy out of the atom, and nothing will change about the atomic number, the charge, the protons, neutrons, electrons. Nothing changes except a lot of energy has been just released. That gamma ray, all right, has a lot of energy and it can do a lot of damage. So that brings us into today. And when we talk about electrons, we talk about them being in the electron cloud. Well, the electron cloud has a few pieces to it. The first thing is that the electron cloud has energy levels, and we break those down into rings. So here to your right, you see a first ring, a second ring, and a third ring. So each energy level, or each ring, so we have the first level, second level, third level, first ring, second ring, third ring, first orbital, second orbital, third orbital. They all kind of mean the same thing. So rings, orbitals, levels, you can use those pretty much interchangeably. So each level is going to hold a certain number of electrons. In the first level, the first ring, or the first orbital, whatever you want to call it, it's only going to hold 2 electrons. So we would fill it up 1, 2. The second and the third rings can each hold 8 electrons, and we fill from the inside out. So we would have to fill up the first level before we can go to the second. We'd have to fill the entire second level before we can go to the third. And we'll get more into how that works in a sec. So with those energy levels, the first one again holds 2 electrons, the second holds 8, and the third also holds 8. So if we filled up the first level, we'd have 2 electrons. If we filled up the second level, because we add in the 2 from the first, 2 plus 8 equals 10. And then if we filled up the third level, 2 plus 8 plus 8 is 18. So every time we go through electrons, we have to fill from the inside out. We start with the first two going to the first energy level, then the next 8 fit into the second energy level, and then the third level is where the remaining 8 would go. So the electrons in the outermost shell, now there are more than the first 3, but there's only 3 that we're really going to be looking at in this class. So we're really going to focus on the first 3 levels when it comes to electrons, but there are more. Like this picture, potassium has 4. Well, potassium here has 1 electron in its outermost shell, and that's what we call a valence electron. A valence electron is an electron that is found in the outermost energy level of that atom. So whatever it is, whether it's the first, second, third, or in this case the fourth energy level that is the furthest out from the nucleus, that's going to be your outermost energy level. And the electrons found out there are going to be called valence electrons. They determine the chemical properties of the atom. So depending on how many electrons are in that outermost level or how many valence electrons we have, that's going to determine the type of reactions and chemical properties that atom will undergo. So one thing, flammability, toxicity, and reactivity. They're all determined by the number of valence electrons and actually how far out they are. And a general rule of thumb, the further out, so the more energy levels, the more reactive those are going to be. There's a little bit more to it, but that's basically what we need to know, that the outermost level electrons are called valence electrons. In this case, we have 1 valence electron. That's going to determine the chemical properties of that atom. Things like flammability, toxicity, and reactivity are going to be determined there. We break that down into what you just looked at, excuse me, is called a Bohr model. And in a Bohr model, we kind of look at it like electrons are planets orbiting the sun, right? So as planets would orbit around the sun, we basically put electrons orbiting the nucleus. And the pathways around the sun are called the energy levels. So, our planet, the Earth, orbits the sun, and it has an orbit, a pathway. It goes around in the same pathway. That's why it's not running into Mars or Jupiter or Venus, right? And these electrons follow the same kind of general idea that they have their own pathway, especially in what we look at as a Bohr model. And that way they don't run into each other. They have their own pathway. Now in this model, we have 1, 2, 3 energy levels, and we have 1, 2, 3, 4 electrons in the outermost level, right? That would be 4 valence electrons. In a Bohr model, we are only worried about the electrons. We're not putting how many protons and neutrons are in the nucleus. So in this model of a Bohr model, we would have, I believe, silicon. This would be a silicon atom with 1, 2, 3, 4 valence electrons. And again, those valence electrons are the electrons in the outermost shell. In this case, we have 1, 2, 3 shells, or 3 levels, 1, 2, 3 levels, 1, 2, 3 orbitals. The rings are, we can count them going 1, 2, 3. We fill from the inside out, 2 in the first level, then we fill in the next 8 in the second level, and then we start filling in the third level. And in this case, we have 1, 2, 3, 4 electrons in the outermost level. We call those valence electrons. So a little bit with those valence electrons in the Bohr model and how far out things go. So energy levels, or the rings or the orbitals, whatever you want to call them, are like steps on a ladder. If you jump off the second step of a ladder, there's not a lot of energy in there. But if you jumped off the fifth, you're going to have a little more energy to get up there. And when you come off, you're going to have more energy going down. So energy levels, it takes more energy to put them further away, those electrons, to keep them further away from the nucleus. It takes more energy to do that. All right. And that's going to result in those atoms having a little bit more violent reaction when those electrons want to change. That's what we're going to kind of get into in the next couple of days, especially when we talk about Lewis structures, that the further out an electron is, the further out it's going to be from the nucleus, so whatever energy level it's on, right, the more energy it's actually going to have. And it's going to change how reactive or how toxic or how flammable that substance is, that element, that chemical. So today you should be able to remember and demonstrate the knowledge from the materials on test one. You can identify how many valence electrons atoms have by counting how many are in the outermost shell, or the outermost level, or the outermost orbital, or the outermost ring, however you want to term it. And then you can correctly place electrons into the correct energy levels, starting with 2 in the first level, 8 in the second, and then 8 in the third. All right. If you have any questions, please let me or Mr. Oleg know. Have a fantastic day, everybody.